Not Year 12, I'm going to go over this exercise again because I'm a bit worried that some people didn't really quite get it. So I'm going to do a couple of these just to make sure you're on top of it. So this method for finding an approximation of the roots, and there's going to be one of two, we're going to learn Newton's method in the next lesson, is about just guessing and checking and refining that by going halfway between whatever interval you are told. So let's start with a nice easy one, and I'll go to question 2. So if I have a look at question 2, I've got a quadratic, and I'm told that f of x equals 2x squared plus 5x minus 2. And they say show that it has a root between x equals 0 and x equals 1. Well, first thing I do is I sub in f of 0. And if I do that, I get minus 2. You can do that on your calculator. Actually, I'll show you the substitutions. So I get 2 times 0 squared plus 5 times 0 minus 2, and that equals minus 2. If I find f of 1, I get 2 times 1 squared plus 5 times 1 minus 2, which gives me 2 plus 5 minus 2, which gives me 5. So I know there's a root between 0 and 1. Now, if I were to draw this is a positive parabola. And if I were to draw this, and even though I'm doing this for this particular question, I'd be going, all right, well, I know what this looks like. But in some questions, you don't know. So I know that this goes through negative 2, because that's what 0 is. And I know that it's coming up there. Now, I don't know if that's a vertex down there, but I know between 0 and 1 there's a root. And I know that, I might just get rid of that red line. I know that at that point, that's 1 and 5. And this is 0 and 2. So I think the root would be closer to 0, right? Because here's 0. I reckon it's going to pass closer. But you really can't make that assumption with some of the other functions that we may have. So since f of 0 is negative, less than 0, and f of 1, I don't even need that is in there, is greater than 0, there is a root between 0 and 1. So x equals something between 0 and 1 will be a root. Well, how do we find that out? Well, we halve the interval. We halve that. So we'll find f of a half. So I put that in, and it's 2 times a half squared. 2 times a half squared plus 5 times a half minus 2. Now, I put that in my calculator. And I get 1. So now I know that the root must be between 0 and a half. Because 0, the value is negative 2. I'll do this in red. Negative 2. And at a half, it's negative 1. So I know there's a root between half, therefore between 0 and a half, because the sign still remains the same. And that's all they asked me for question 2. to show that there is a root. So therefore, the root between x equals 0 and x equals -half. Because, and sorry, that's positive 1. All right, positive 1. Let's go on to another one. Let's go on to question, I think 6 asks us to do 2 applications. Okay, I want to do 6 because it asks an interesting question. So that was question 2. Let's do 6. So they tell us that f of x squared plus 5x plus 1 has a root between -4 and -5. So we don't have to show it. They say there is a root -5 and -4. All right, well, I'm going to find them anyway. So f of -5, and I'm not going to go through this time. I'm going to put this in here, is equal to 1. And f of -4 is equal to -3. Now, if I were to draw that, and here's -5, and here's -4, if I were to draw that, now I have to be careful here because you can't make this assumption. That's 1 unit above, and that's 3 units below. Now, we know that the parabola would be doing something like that. It might be steeper, it might be doing something else. But we don't know. Sometimes the function might not do that. Sometimes the function might go like that. Or sometimes the function might go like that. So you can't really tell where this root is just by how far above or below the axis it is. You would be guessing that the root is closer to 5 than it is to -4, but you don't know. In this case, we sort of do because it is a quadratic and we know that it's going to be pretty stable and it's not going to turn or deviate really between those 2 values. All right. So here we go. The rest of the question says, by halving the interval, find that the root lies between -4.5. So we're going to find -4, what happens there. So at f of -4.5, and I put that into my calculator, and I get -1.25, which makes sense. Yep. So now I know that the root lies between -5 and -4.5. And then they say, well, which is the better one? Well, you're going to go with x equals, oh, sorry, I was going to do approximately. X equals approximately -5 because it's closer. And we know that there's not going to be much deviation. At -5, it's 1 unit above, whereas at -4.5, it's here it's 1.25 below. So the root is closer to -5. But I don't like that method there. I would probably say the root is closer to halfway between those two. So -4.75. And if I found f of -4.75, which I've done, it comes out at -0.1875, which is a much better guess. So be wary of doing those ones. Okay, so this guess and check method. I want to do question 12. All right? So 12 takes us through this bit. It says P of x equals x cubed minus 12. Now, we know what that looks like. We know it's x cubed, and it's down here at minus 12. So it's doing that. Now, we need to show that it has a root between 2 and 3. So here we go. F of 2 equals. So 2, I'm going to go 2, and I'm going to use my answer button here, which is answer cubed minus 12. And I get negative 4. So I know it's negative 4 there. At F of 3. So I go 3 equals, go up, and I get 15. So, therefore, since f of 2 is less than 0 and f of 3 is greater than 0, there is a root between x equals 2 and x equals 3. All right, what was the rest of that question? Using a method of halving the interval twice, find an approximation. Well, this is what I'm doing, x cubed minus 12 equals 0. That's what I'm finding. I'm finding when x cubed equals 12, and I'm finding when x equals the cube root of 12. So I'm actually finding a solution to the cube root of 12. So let's halve the interval. So let's try f of 2.5. Now I've left it in my calculator, so I'm just going to go 2.5 equals, scroll up, press equals, and I get 3.625. And I look back and I go, well, it's between 2 and 2.5. Therefore, 2 and 2.5. Well, they said do it twice. So let's try f of 2.25. So I've still got it in my calculator. So I go 2.25 equals, I go up, equals, and I get negative 0.60935. Now, therefore, my root is between 2.25 and 2.5. Now, what do they want to find? They want to use a method of halving and find an approximation. Now, here's where you're going to make that decision. It's somewhere between there. What I would be taking is I'd be taking the halfway mark between those two. So I'd be going x between those two. And I'm just looking up what Margaret says here in her answers, because she sometimes just goes to the closest one. Now, I know that this is my more likely answer because it's only 0.6 above, whereas 2.5 is 3.6. So I know Margaret's going to go there, but I just want to double check and see that she's making the right decision. So I'm getting there. Question. I'm going to get to exercise 9. Chapter 9, question 12. Now she's gone, as I would have thought, x equals 2.25. Whereas I probably would have gone x is halfway between those, and if I add 2.25 to 2.5, that's 4.75, and I go 4.75 divided by 2, I get 2.375. Now, if I now use my cube root button, so I go the cube root of 12, and I get 2.28. So yeah, she's better off, but I could have halved the interval again. So that's halving the interval. And hopefully you have a better understanding. So what you have to do, if there's a show, you show that the sign changes between the two values that they give you for x, and then you halve the interval. But gee, you've got to be careful of assuming that this point is going to be further away from the root than this point, just because they've got a bigger distance between the curve. Remember, you could get something. Now let's assume this is not true. So imagine this. Here's 2.25, and here's 2.5. And we know 2.25 is negative, so it's negative 0.6, and this one is negative 0.3, so it's a lot further. But if you didn't know what the curve looked like, this curve could be going like that, in which case 2.5 is actually closer to the root. So making the assumption that 2.25 is the answer sometimes can be fraught with a little bit of danger. So be careful of that one. Anyway, there we go with those. We'll continue with those tomorrow in HSC questions, and then we'll move on to Newton's method.